Hello everyone, today I will discuss direct integration method, which is a numerical method to solve differential equations. In particular, I will discuss three coupled equation, first order differential equation, uh, uh, to solve them in MATLAB. I'll use an example to show you how we can solve it in MATLAB. In direct integration method, we required three boundary conditions for three first order differential equations. And another important requirement is that we need y1, y2 and y3, boundary value of y1, y2 and y3 for a single value of t, which is t is equal to 0 in this example. We'll solve it from t is equal to 0 to 100 seconds in this case. So you might have seen this Euler's formula, which is y next, the new value of y1 is past value of y1 plus f1 into dt. We'll break this whole time from t is equal to 0 to 100 seconds into small parts of dt, and we'll calculate the y1, y2 and y3 from these three equations. Now let's go to MATLAB to see how we can solve it in MATLAB. So I'll first define the initial conditions, which is y1 is equals to 10, y2 is equals to 10, and y3 is equals to 0. Now we want to solve it from t is equals to 0 to t is equals to 100 seconds, and we would like to take t is equals to 0.01. So better practice is that we first define total number of steps that we want to take from 0 to 100. So let us take 10,000 steps. Then define dt as function of t1 minus t divided by n. So you can change the total number of steps, so the dt will decrease and the accuracy will increase. So you can do it easily. After that, let's put a loop now. Now, as we know that this loop will run for n times, and dt has value such that after the loop has been run, the t will take the value of t1 at the end of the loop. Next, we want to put our differential equation in a numerical form here. So which is y1 is equals to y1 plus dt into f1 divided, second is y2 is equals to 2 plus dt. Now f3, f1, f2, f3 can have any functional sum depending on y1, y2 and y3 and t. So in this case, I'll take an example in which f1 is y1 minus y1 plus 2 into y2 and f2 is y3 minus 1.2 into y2 and 3 is minus 2y3 plus y1. So now it will solve our differential equation, but you all might know that in any in a programming language, first the right hand side of an inequality is calculated, and then the value is given to y1. So here it will use the ith step, value of ith step of y1, and give it to the next step, to the y1, which will be the new value of our variable. So you might be knowing this using because you might have used Euler's method. But here one thing is that here y1 gets modified, but we are using y1, the value of y1 which was in the last step here to calculate y3. Mm, so that we cannot use this y1 because it is modified, so we will require to store uh, y1 in another variable first, then we'll calculate modified y1, and here we'll use the last value of y1. So now another thing is that many people uses this y1, y2 and y3 as a matrix or an array of 100 10 100 times long. uh, so whenever they call y1, y2 and y3 from the memory, or they store the value of y1, y2 and y3 in the memory, the MATLAB requires to call this 10,000 times long array to call and store the value of this much long, which takes enormous time. So a better practice is that um, uh, we store value of y1, y2 and y3 and in a matrix in this way: y1, y2 and y3. So in each step our our, our P is a matrix of length, a matrix of dimension 10,000 cross 3. So for each row, it will store the value of y1 and y3 at each step during the evolution of t. And when you plot this p, you will get the evolution of y1, y2, and y3. Wait a minute. Okay, there is a problem. Okay, the another thing that I want to discuss is that if we use this equation in this form, it takes more time than the another method in which we use matrix to write this equation in a different form. So it is always time saving to use matrix form of equation to save. So I'll change this equation in matrix form. For that I'll require to first define a vector uh, which has values of y1, y2 and y3. This is now my new boundary condition, so I will not require this. uh, so the first, second and third element of this vector is y1, y2 and y3, and then mm, I use this equation: y is equals to y plus dt into matrix into y. So I need to define a matrix A over here, which will be according to this equations. uh, so my A will be um, -1 2 comma 0 0 -1.2 comma 1 self dot equal to 1 comma 0 comma -2. So you will, if you use this equation to convert it in matrix form, So once we put A in this form, we'll change uh, this P also, because our Y is vector. We'll need to use this way, and then if we run, run this, we'll get similar results. But this method, if our code is too big, takes very less time than the earlier one, so you can use this method. So in question 2, I have used this way to convert my equations into matrix formation, which you can see here. Thank you.